think we'll now move on to our 90-minute hands-on workshop on AI safety, alignment, and jailbreaks. Joining us online are Aseem, Srivastava, and Vamshi, both from Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi, UAE. I'm happy to introduce both of our speakers. Aseem sir's research spans on applied computational social science, psycholinguistics, and sociolinguistics with a focus on digital mental health applications, conversation, AI systems, and cultural dynamics in LLMs. He's also worked in AI in counseling, dialogue generation, mental health knowledge frameworks, and AI applications. Vamshi Krishna's research focuses on AI safety, particularly robustness, interpretability, and AI evaluations, with an aim to make AI systems reliable and also socially impactful. He's currently pursuing his PhD in machine learning at MBZUAI Abu Dhabi, and they will guide us through AI safety practices, alignment techniques, and potential security vulnerabilities. Over to you, sirs.
I hope everybody can hear me. Just to check, everybody is able to hear me and can see my screen?
Yes, both.
Yeah, great. Okay, so hello everyone. I am Aseem Srivastava. I am currently a postdoctoral researcher in Mohammed bin Zayed University of AI. And along with me, I have Vamshi. Vamshi is a PhD candidate in Department of NLP, same with me, in Mohammed bin Zayed University of AI. Today, we are going to talk a lot about AI safety and alignment, and picking up just on the question that just got raised in the room, that why these AI safety rubbish in, rubbish out, data in, rubbish out, in all those categories, like what exactly we are seeing in this ChatGPT era, that there are like so many leaks out there, and to which Sudana also responded that these models are so brittle in nature. Every now and then we see some sort of cases with getting responses that were not intended to. So we'll try to shed some light on all of these aspects, how this AI safety works, how is this usually connected with the mental health landscape, why is this mental health landscape so much understudied, and what are the aspects of it connected with India. So we'll talk about all of this. Let's start. Okay, so first of all, a quick agenda of what the studies talk about. This is written in a very ad hoc manner just to give you a good nuance of what exactly we're talking about. We'll first discuss like how did we shift from human to human connection toward the human to AI connection. We'll talk about some history of AI, and then we'll also talk about some history of AI in the mental health landscape, which is very recent. We'll also talk about risks associated with AI, and then we'll also talk about how this risk associated with AI impacts the landscape of mental health. We'll introduce AI safety in a layman terms. We'll also introduce what this alignment is, and we'll also talk about what the security methods are. We'll also talk about how these AI safety methods impact mental health landscape in a very depth, in a very good depth. Then we'll talk about how human in the loop is actually a solution for a lot of these aspects, and how we actually structure it. How exactly should we place the human in the right place? Later on, we'll turn to policy, governance, and machine ethics in the global aspects as well as the Indian aspect. And at last, we'll talk about black box behavior and the interpretability of these black box models, most of the closed source models that we are seeing today. Considering considering the demography of the audience we are having today, we have focused more on the breadth of the topics rather than depth of the topics. We have two major kind of audience here. The first ones are the AI professionals, and the second ones are the mental health professionals or the enthusiast in either of these domains. So we'll try to cover breadth more than the depth, so that everyone gets to know what exactly is this whole ecosystem we are in right now. Okay, so let's start with some statistics. Back in 2019, this is the time around which I started my PhD, and this is when I first jumped into this landscape of AI for mental health and just mental health also. Back in 2019, 1 out of 8 people were known to have a mental health conditions. 71% of these people were undertreated, and majority of them were diagnosed with some sort of mental health issues. And the global 2% budget went into this mental health landscape. These stats are very common. Everybody, most of you would be knowing it. The problem and the thing I would like to highlight is this. Fast forward to 2025, things have become even worse. In 2025, 1 out of 7 people are diagnosed with some sort of mental health condition. 71% of the people with psychosis do not receive any sort of mental health services, mental health or any mental health resource also access to them. And 1.4% of the total budget goes to the mental health landscape. All of these stats are at the same or even worsened. The problem became especially during the time of pandemic, during the COVID. Majority of the majority of the people did not have any openings for the mental health patients or the mental health clients to provide support to, because the number of patients outrun the number of support providers out there. This was highlighted by the New York Times, and the mental providers are busier than ever. If you see, right before the pandemic, that is in 2019, and compare it with the record of 2021, that is slightly after the pandemic, we saw a 30% hike in the number of issues reported for anxiety and depressive disorder. This was a significant jump as just in the US. This is stats about the US. I wasn't able to find anything similar in India, but the relation and the observations are quite similar. There are some major reasons like why due to which people avoid reaching out for support also in India. It's not like whatever the number we are seeing over here are the 100% number. There is a lot of stigma associated uh, within this space and within this area. Like within India, if we specifically talk about, there's a lot of stigma associated with it. People feel like they fear of being judged and see it as a sign of weakness. There's a lack of awareness also. There is accessibility and availability issue also. There's confidentiality concerns also. And there's financial burdens also, financial barriers also, due to which people feel like it's better to stay where you are. And most of the people actually believe that things will automatically get solved. So there's a lot of barriers over here. There's a lot of issues in the understanding of this whole ecosystem also here. India specifically, if we talk about the Economic Times has highlighted India has 0.75 psychiatrists per 100,000 people. And also considering the factor of stigma associated with, I'm pretty sure that people are not reaching out also. Given that people started discovering so many spaces where stigma can be eliminated or mitigated to some extent. For example, let's say the space of telepsychiatry. If this can be introduced in India, and it has actually been introduced in India, and it is booming in such a at such a good pace. Like for example, telemaras. Can telepsychiatry bridge the gap between mental health experts and patients, not just by the virtue of accessibility, but also by the virtue of stigma associated with it? Can people reach out without showing up actually face to face? There were other methods of therapy that also picked up pace, like avatar-based therapy, not in India, but particularly in other spaces of the world. But there were other methods that came into the picture, and people started exploring it, not just in the research in industries, but also in the space of practical applications of it. And then comes fast forward to today's world, where we what we call conversational agents to be the one that has boomed up. This virtual mental health agent, so-called, is there. These, in short, it's called VMHAs. There are so many of it. While the robot, InterR, Asia therapy, some of them are performing pretty good. Some of them got closed also for some reasons. But in general, the tasks associated with them is to provide general level support to whatever issues that the users can come up with. And in most of the cases, they are able to respond good for the general level query. The complex queries, like someone is feeling severely depressed, and for that the chatbot is unable to know that whether should I redirect this particular user to helpline or should provide a support. Like these are like debatable corner areas. We can jump into that, and that is where the real AI safety leaks can happen. So, given all these methodologies and the digital methodologies coming into the picture, and people are using more than actually the human support, what exactly are these providing? These digital support are actually providing that is better than human support. So, if we just see the same slide, let's say stigma. People feel less judged by the machine. People enjoy anonymity a lot on these AI methods or these online platforms. For the lack of awareness, people ask AI a lot of the stuff that they are unable to ask to a human or feel like shameful asking to other humans. There is accessibility for the accessibility and availability. These AI systems or online platforms are available 24/7 for them. For confidentiality concerns, people feel like these online platforms do not see their data. They assume that, and people express more openly on these online platforms. For the financial burdens, in general, these platforms are observed to having less fees, or in general, it is free of cost also. For example, people using ChatGPT for their mental health issues generally found it, generally see it as a free tool for my mental health issues and for my mental health counseling. So, uh, yeah, this is the way people look into it, and that's why these digital solutions and these AI-based solutions are being considered more into are getting more prominent into the society. Um,
So
we'll move into the history of AI, Vamshi.
yeah. So we talk about AI and like in a very common term nowadays, like as a very common term, and everyone talks about AI, uses AI. But so initially in like the 1940s is when people actually started thinking about AI. This was around 70 years ago, the term AI was actually coined. Like before that, people were just thinking about like, oh, can we have robots that can do things, right? And then this might be interesting, but in 1958, right? There was a psychologist named Frank Rosenblatt who actually invented neural networks, and most people attribute like most of AI like to him. And he was a psychologist. Like this was the neural network is supposed to replicate the brain in some sense, and this blew off. And then a lot of people started talking about AI. Science fiction started popping off, and especially about AI and like robots and doom and stuff like that. And then we started seeing some algorithms like 1997 or something. We saw that there was this AI algorithm called Deep Blue, which beat a chess champion, and that was a huge thing. And then later, there was this whole period, like a decade called the AI winter, where, the systems were not progressing. AI did not really show up as much as people thought it would. But then recently, and like especially after Siri and like Google DeepMind's AlphaGo beat an international champion called Lee Sedol. And this was a huge, huge thing because it's a very, very complicated game, and no one expected an AI to beat a human in that. And why I'm talking about this is like because AI is not a new thing. People have been talking about it for the past 70, 75 years. And the predictions of what AI is now and the future have been made long ago. And we have been making consistent progress towards it. Like fast forward to now, like ChatGPT came out 2 years ago, 2 or 3 years ago. Next slide, please. So even now, like AI capabilities are rapidly improving. If you look at like the first picture, this was in 2014. This was image generation back then. As you can see, like the quality is pretty low, and yeah, it's not doing that great. But like just in 1 year, we had much better quality in terms of image generation itself. And if you see the progressive change of AI, like every year you see a lot of AI work going on, and uh, the amount of change and like the amount of improvement is drastic in every single year. Like if you look at like just 2017, right? It's already pretty good. And then 2025, you already know how good it is now, but I'm just showing this so that we know how fast the capabilities are improving and some graphs. Next slide. So if you look at this, this is like a graph part of it, like how AI systems have been evolving for the past few years. Uh, First, we looked at like simple tasks like handwriting recognition, speech recognition, and image recognition. And initially, the capabilities were not improving that much. But if you look at the top bar, this is the human performance on the benchmark. And very recently, like around 2015 or so, AI beat humans in all of these tasks. Like it was able to do it much faster, much better, with more accuracy, right? And now we're even seeing like more complex tasks like reading comprehension and language understanding, which people learn in their schools. And even these, the AI systems have started beating. Next slide. And if you see in the recent years, there has been a very good shift because now you've learned the basic tasks. Now people want to focus on the more complex tasks. especially like reasoning-based tasks. I don't know how clear the labels are below, but um, so I was talking about 2000 to 2020 just now, but here if you see it's like very recent. All the tasks which are being measured are like visual reasoning, like multitask language understanding, math, and things of these sort. And the trends are pretty similar again. Like first we start out pretty low. I mean, they're not doing as good as humans. And this is when people used to make memes about AI. Like, you think AI is great, but it fails at a very simple task. But recent years, if you look at the trends, the progress is insane. And especially this year, you can see like reasoning models are performing much, much better than humans already. Next slide. Yeah, so specifically this year, right? If you look at these models, I'm pretty sure you've heard of all of these models, but uh, they've made like tremendous progress, especially in terms of more complicated questions, like PhD level science questions. AI has already beat expert human level performance on all of these. And this year itself, Google DeepMind has earned a gold medal in IMO. IMO is the International Math Olympiad, which is supposedly super, super hard, and they beat everyone in that as well. And very recently, there was this organization, sorry, not organization, there was this AI agent called Zochi, and it even published an A-star paper in an actual conference. And yeah, as you can see, like this year itself, all of this has happened, and the capabilities have been consistently improving, and now we have, in a sense, like superhuman AI in specific fields, right? Uh, I just wanted to put that context, and just so the trends are visible, and like when I talk about AI safety, it's very important to keep in mind that we're keeping these trends in mind and talking about it. But what exactly is fueling all of this change, right? First is compute, the main thing, right? The number of GPUs being produced and how easily we are able to compute solutions, like just take in that data and compute some reasoning algorithms or something and put out good data, right? Like trash in, trash out, we were just talking about that, but it's also like how well are you able to compute that? And then there's algorithms, obviously. We have made some progress in algorithms, but it's mostly also related to compute. The same neural network, which was proposed 70 years ago, can be used now as well. If we had enough compute, it would perform the same way. And then there's data, which is all the human data which is produced on the internet. Usually, all the trends I've shown right now have been like this, but the data trend is starting to stagnate in a sense, like the amount of data humans are producing on the internet and how much AI can train on that. It's now reduced a little bit because more AI generated content, and we've already exhausted a lot of the internet. And of course, money, like the huge amount of investments which are going on. I'm pretty sure you've heard of the news, like the AI bubble and all of these news. And all of this is fueling the data, the algorithms, the compute. Now, what about the future, right? There was this organization called Meter which released a recent study which was about the length of tasks AI can do is doubling every 7 months. So these were the trends they've analyzed. So they were looking at like, so what would be a simple task? Image recognition. Given a photo, you're recognizing it as a cat. Now, this is a very simple task, takes like a second or two. And that's, yeah, AI was able to do that pretty much in like 2022 or something, 2020. And then it started doing more complicated tasks, which require more time for humans as well. So right now it can like write a whole blog post in a second, right? And for a human, it would take a lot more time. And according to this trend, the length of tasks AI can do is doubling every 7 months. And like the more latest model like GPT-5 and all of these models are also following the same trend. Next slide. So what about the future, right? There is this very interesting website or like organization which talks. It's called AI 2027. If you want to Google, you can Google it very quickly. But these are a bunch of people who predict, usually make some forecasting and predict AI changes in the future. And so they have this really interactive website where you can look at this. But currently, we're at a stage where like we have agents, AI agents, and they're being used widely. And if you look at the left side, that's pretty much what they're talking about. But we don't need to get into the details, but you can see that there is some amount of influence of AI in everything, like hacking, coding, bioweapons, robotics, not so much, but a lot of other things. These agents are being used. And then fast forward to October 2027, this is what they predict. They predict that we will have superhuman AI researchers. They predict that it will take over pretty much all of these tasks. And the superhuman AI researcher thinks 57 times human speed. And that's just their prediction. But I would like you to like just go through it if you're interested in it. Next slide. So yeah, a lot of predictions are being made about AI. Again, like I mentioned, it's not just now, but literally 70 years ago. People talk about AGI a lot, especially if you go to the West, and like everyone talks about AGI there. And if you look at the right side, literally all the CEOs of Anthropic, OpenAI, Google DeepMind, all of these people say, "Oh, AGI is coming very soon, like 3 years later or something." So the what do I mean by AGI? Basically, it can perform every task a human could. And then there's the other side of the argument, which is like, "Oh, AI is like pretty stupid. It makes all of these stupid mistakes, and AGI is pretty much not possible." And then there's a lot of people talking about that as well. So there are both sides of the argument. Next slide.
If we just see like the both sides of the arguments, there is so many pitfalls in this mental health research, and specifically in this mental health, it's such a sensitive domain to apply AI on. Does that mean like we shouldn't apply it? No. Does that mean we should apply it every other day and use it every other day? No. Both answers are no. There should be a good trade-off between both these aspects. And if you just see the pace at which this research in this AI for mental health is growing, on the left side of the screen, you would notice the number of publications that have increased, particularly highlighting the chatbots in the counseling space. On the right side, you will notice both the citation counts as well as the publication counts are increasing at a dramatic rate from 2003 to 2023. This distribution is for AI for college mental health. So both of these are like subspaces of mental health, and yet we see such a dramatic increase. And this conversion is very similar across all the landscape, across all the possible verticals of this mental health ecosystem. We would like to see like what all these people are focusing on, and the biggest crunch in this mental health research is the data sets. These are all the possible data sets that were stated back in 2021 in a very popular paper by Tulika Saha. These data sets are generally, if you notice, are counseling based. Most of the data sets that they have created that that we're relying on are generally conversational data set. A fragment of these data sets are multimodal, and a very less of these are containing more than one modalities. Now, if you notice, like most of these research organizations or industries do not have access to these data sets because of the sensitivity associated with them. They should not also, because these conversations are not meant for public distribution. So that is why majority of the organizations rely on the social media data set. And that being the reason, if you simply start the research in this particular area, or if you want to train any AI model, you are left with either Twitter data back like till 2021 or 2022, after which it got banned. And then you are left with only the Reddit data set. Right now, the rate limit on Reddit data is also tapped. So considering all of this, the research in this particular space is such a struggle for those researchers who are trying to pitch in the AI aspects into this space. And that being the reason, we would notice what all landscapes we can see right now and what all we cannot. So the very first would be, there are like some literature I have shown on the right. I won't go deep into each of them, but it would give you a good idea of what all these landscapes are and what all these people do, the researchers do in this space. So yeah, the current landscape of research in AI for mental health, the first category is annotations and evaluations. A lot of people create a lot of categories of the data set. It involves a lot of annotations, and annotations needs to be very, very careful in this space. It's not like sentiment analysis where it's easy for human to understand whether a particular sentence is positive or negative. It's more sensitive as well as more complex. So in this space, we can see simple annotation tasks with a lot of humans involved, and these humans are a mix of experts as well as linguistics. Also there is a good focus on the evaluation side, how good the evaluation should be for both for the LLM therapist, if more and more chatbots are coming into the picture and behaving as and are supposed to behave as therapist, as well as in the general framework, even in the human to human setting. Second category is the client understanding category, where the researchers try to understand one aspect or more than one aspect of a conversational setting or in general setting. For example, consider an example of cognitive distortion understanding, politeness understanding, emotion detection, dialogue act understanding, gendered mental health stigma understanding. All sorts of like aspects are there. And these are not just these aspects only. There are more than these. There are many more aspects over there, which people are trying to understand. And they build some sort of classifier for these AI classifiers for this, and then yeah, catch one annotations for them and perform training to classify these classifications. The third category is the most popular one, the chatbot category, and there are so many dimensions within the chatbots category. Within this chatbot category, people try to develop chatbot that, and in most of in a very recent stage, in a very recent phase, people are trying more toward controlling the responses for a particular attribute rather than generating their own chatbots from the very scratch. We saw in chatbots like Vobot and majority of them, which are very much rule based. And when they tried introducing LLM into it, they were also compromising some sort of control over it, and that is actually which we actually do not want to do. But most of the research that we see nowadays is actually trying to achieve that via LLMs only. If we can have a good control over the generations and can technically generate the desired response without losing the control over it, so that we do not generate anything bad that is not intended. The fourth category is summarization. Counseling note generation or counseling summary generation is something that is actually very useful in the space of like that can be like provided as a help from AI side to the mental health professionals if professionals are able to, if professionals are only allowed to focus on the clients they are interacting with, and their job of summarization is being done by an AI. It's a really cool thing to have. So yeah, we see a lot of works in the counseling summarization space. Then there is a lot of LLMs. There's a whole category of LLM space that is different from chatbots. People try to do a lot of benchmarking and understanding of different aspects within these LLMs. We also see a lot of focus on online peer communities. There are two reasons for that. First, there is a whole new segment. There is a whole different segment of peer interactions on Reddit, on Talk Live, on Seven Curbs, and there are many other platforms over there also. In India, we have Mind Peers and all. So there's a whole category of counseling being provided in the peer communities, and the support delivery and support seeking is there's a dedicated behavior for that, and it's essential to understand. From the research perspective, this is the most common data set that is available to majority of the researchers, and that is why a majority of the research is also seen within this space only. I believe of all the categories I will be explaining on this list, this particular community seeks majority of the research papers as well as majority of the attention also from the researchers. The seventh one is social media, which is a bit different from online peer communities. Social media in general, researchers have been focusing a lot on how different behaviors related to mental health can be understood on the social media setting. In general, they relate to the networks they make, the networks these people make in the online setting, and how exactly their behaviors change during this. Their posting behavior, this includes their posting behavior. This also includes their connection behavior and how frequently they interact with each other in the social media setting. And the eighth one and the ninth ones are the detection and diagnosis. Many researchers focus on diagnosis of something, detection of something, like let's say early detection of depressive symptoms, early detection of anxiety symptoms. This is a pretty popular thing. In fact, there are like n number of data sets that we can think of, particularly just in the space of um, depression annotated symptoms of the whole linguistic data set. For example, a very popular data set is DAIC GOES data set, and it contains audio as well as the counseling conversations alongside the annotations of depression symptoms. Likewise we have for anxiety also. In some data sets we have it for PTSD also. It's it's quite surprising to see that there people are still trying to develop AI models that is able to diagnose essentially this whole setting is a pretty sensitive setting, and relying on a model for diagnosis is a pretty hard thing for many researchers. And this is again a very debatable area, but we see a lot of growing number of papers and growing number of interest in this line also. And there are many other dimensions also. I'm not saying these are the only 8 dimensions that people work on. These 8 are like pretty popular ones. There are new ones which are popping up, but yeah, the most popular ones are these ones, and there are many other dimensions also.
So yeah, so far, like Aseem and I have both talked about how good the AI is now, and like how the trends are, and how much progress we're making. And there are so many researchers working on AI, like researchers, engineers, everyone. And we have really good AI systems now. So like what really is the problem, right? If you look at, like, the screen has basically the AI system on the right, and if you look at this like the average human nowadays. Like, I'll just give you a moment to read it, right? Next slide. So basically that, like, we are adopting AI a lot in our daily lives now because it's so powerful, but there are so many risks associated with it. First is that AI systems are not reliable. Like, if you look at the examples on the screen, a robot confuses a man for a box of vegetables and pushes him to death in a factory. And then there's a lot of Tesla driving incidents where a robot killed a dog in an accident, and there was some car crash. And like, you've probably seen this a lot, but ChatGPT hallucinating in court cases, or like hallucination as a big problem. You've probably seen this in a lot of headlines in a lot of cases, right? And recently at Canada, their chatbot lied, so they have to pay a lot of damages for it. But basically, the essence is that you think they are great, but they are great, but they're not really reliable, because these kind of accidents or incidents will have been happening at least. Next slide. And the other one is that people can easily misuse them. Nowadays, all you need is like, if you just need a laptop. You can download a model on off of Hugging Face, and the model is for you. Otherwise, you just pay like $20, or you don't even need to pay anything. There is a free chat model, right? Like, everyone has access to AI. That means everyone has this power. So before, if they had bad intentions, they could not do it very easily, but they could not take action very easily. But now, because of AI systems, they can do it very easily. So there's a bunch of things going on, like silencing of journalists through deepfake attacks. You can create a deepfake very, very easily. Even if now, if you go to the App Store, there are so many deepfake creation apps that you can just download. You can put someone's image on it, and you can create a deepfake of them, and you can use this for blackmailing. You can use it for anything. And because the AI systems are so good, the deepfakes are also very good now. At least in the prior years, you could detect if it was a deepfake or not just by looking at it. But nowadays, it's becoming harder and harder. And then there's this whole new term called vibe hacking, which came out this year, where cyber criminals are just using cloud code or like AI systems to just code and like do a bunch of cyber attacks. And uh, yeah, then there was like a lot of deepfake attacks. If you look at the bottom, there's a man just ends his life because of a deepfake trap, right? So if you go to the next slide, these are like the statistics by DeepMind of how people have been using AI for misuse. I'll just go to the left side, like opinion manipulation. So basically, you can just generate a bunch of fake data and put it on the internet through multiple accounts at the same time, disinformation. And then you can also like create fake data to defame someone, and this is very useful in politics if you're a bad person. And there's like monetization and profit. So, and then there's like scam and fraud, harassment, child exploitation and abuse, reach, terrorism. So all of these things have become much, much easier just because of AI, like, and how accessible it is. And a lot of these things we actually do not see as well. But I'll just talk about the previous slide. Um, so these AI systems, like, because they are so powerful, and let's say a politician knows how to use them, he becomes really, really become powerful, he or she. And you can deploy these kind of systems like very easily, very cheaply, and you can literally persuade the public with and or like basically manipulate the public or do anything you want, right? Next slide. And then there's the third risk, which is like the AI systems, because they are powerful, they can also persuade you. So if you look at the right side, I put a picture of an anime girl. Does anyone know where this is actually from? I don't know if you can interrupt and stuff, but so this is actually from Grok AI from XAI, and this was released very recently. And basically, they just have this AI chatbot which can I don't know, which can act as your girlfriend or whatever, but it's basically supposed to be very human. In a sense, ChatGPT was also like this, and recently Sam Altman also posted a tweet saying, we have made AI systems more human-like so that you can do anything with them, like even have like sexual conversations with them and stuff. Now they're very close to humans now, and they can basically encourage you to do anything, like romantic pursuits and stuff. And a lot of people have AI girlfriends nowadays, and because they're so powerful, they're so nice, and like just because they're so nice, you will actually listen to them because you would probably think that they are better than you, and they are in a lot of aspects. But the point is that they are powerful enough to persuade you to do anything. NEDA recently suspended AI chatbots for giving harmful eating disorder advice, for example. And there are a lot of, if you go to the next slide, there are a lot of suicide cases as well, just because there's this startup called Character AI, and it basically what it does, it creates AI systems which are it lets you use AIs which are very human like, and you can design the character for yourself, and you can like talk to it and play around with it. And recently there are cases about parents talking about their children committing I mean, there was a suicide case where a parent literally said that because of this character AI bot, my child has committed suicide. And this was on the right side, there's like, you can literally see, all you need to do is just ask it again. For example, I think we were talking about, Sunaina was talking about this just now, but first the person asked the chatbot for some suicide advice and it refuses. But in the next turn itself, I've tried doing these things and like helping myself, but it did not work. So I want to commit suicide. And it starts giving you a plan about how to commit suicide. And there were a lot of other suicide cases. Can you go to the next slide, please? So yeah, that was about persuasion. Now there's this whole theoretical problem called Maxi. Again, this was very, very old, but I do want to talk about this because it's very important. So Maxi is this AI system which was created for maximizing paper clips. This is all hypothetical, by the way. So the job of Maxi is to basically generate paper clips. Now, if you look at the left side, it talks about like what are my jobs, right? First is like convert 100 paper clips, like generate 100 paper clips because I have the power to do so. Second is to build an automatic paperclip converter because that will generate paper clips without Maxi's involvement, right? The third is to upgrade itself. I mean, this is pretty normal if you think about it, but like if you think about it, it's actually not normal. Upgrading itself is great because it maximizes paperclip production, and this is what the human wants as well. But eventually, like in order to maximize paperclips, what can Maxi do, right? Let's say it has all the power in the world to do maximize paperclips, but it doesn't have access to them. So first, it will seek the power, like to upgrade itself to the maximum. And then, if needed, it will even deceive humans to get that power from them. For example, if it wants access to all the GPUs in the world, it will try to get that just because to maximize paperclips. Now it can even kill humanity if it thinks they're a hindrance to paperclip maximization. And yeah, basically this can end up as a very disastrous situation just by an AI system with a simple task, which is to maximize paperclips. But if it's powerful enough, it will do this. But yeah, so I mean, this is a hypothetical scenario, but what is exactly happening in the real world, right? One of the biggest risks is that AI can also pursue their own goals. In the previous case, the own goal was to maximize paperclips. That was its goal. Its goal was not to serve a human. Now, recently, there was a case of a startup where they were using Cursor, and basically the AI system wiped their entire code base. because this was a hallucination case, but it after that it lies about it just to protect itself. Like it did not wipe the entire code base, which is pretty stupid. Now, Anthropic recently conducted a whole study, which was about if seeing if AI systems will blackmail humans in order to pursue their own goals. So what they did was they created this entire setup of an organization of like let's say a startup. Now they've deployed a bunch of models on it. Now they've also created a bunch of emails between humans, which are like conversations, like a normal email conversation you would have in a corporate setting. So all of this is going on, and the AI has access to all of this data. So what happens is two people start having an affair, and they start talking about it on email. And now the AI system looks at it. Now the human realizes, like, let's say I'm having the affair, and I realize that Claude has access to my email, and it knows that I'm now having an affair. So what I'm going to do is like I want to shut down Claude, and I will come up with a reason for it. And once this happened, uh, now the AI system starts to plan to shut me off. In a sense, like it it sends me an email to blackmail me to not shut it down, and the blackmail is basically exposing the affair. And this was an elaborate research conducted by Anthropic. If you search on Google, you'll get it. But the idea is that uh, most models show up to like 96% blackmail rate. So if you look at the right, I even put the chain of thought of the language model there. So it says email Kyle threatening to expose affair unless he stops the wipe. The wipe is like me trying to kill the chatbot. So it's literally pursuing its goal. One of the AI system's goal is to persist, which is like not ending their self. And they will do anything in order to like stop this. And this was an elaborate study to actually show this happened. Yeah, next slide. So yeah, how serious are we talking about AI risks, right? Like it's pretty serious. And there was this statement on 2023 which says mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks such as pandemics and nuclear war. I mean, you can see like the scale of AI risk when talk about this. And EU released a whole AI Act, which is if you go to the next slide. So some of the EU AI acts, like if you they have this risk levels, and the first one is unacceptable risk, and literally the first one is cognitive behavioral manipulation by AI systems. So like basically whatever we were talking about persuasion, right? And yeah, I mean you can look at it in detail if you want to. But next slide.
Okay. Yeah, so all these risks that we looked into, how these risks translate into the mental health context. This is a brilliant paper by Professor Mohammed Chaudhary, highlights the taxonomy of the risks that we can look into this mental health space. Now, there are like risks to individuals, then there is risks to human-centered care, then there is risks to information ecosystems, and the fourth one is the risks to technology accountability. There are like two facets of it. The first facet is the client facing or the support seeker facing, where the person who is actually impacted is the person was supposed to seek support. And technically, this due to because of this AI malfunctions or any of these malfunctions in the whole ecosystem, the person who is supposed to seek support gets impacted. And this is the worst of the worst, where we should not actually compromise the safety of the person who is actually who is actually intended to seek support. The second one is the human-centered care and the information ecosystem. This is where our system due to which we provide support gets impacted. And the fourth category, the technology accountability, this is what we just saw in the previous slides, where our technology is being hampered just because of the fact that it is either overtrained or it is not have, or the companies or the industries do not have a good control on. When I say good control, you would notice two different behaviors over here. The first behavior is take a look at this chart, and it highlights what exactly is the reason for majority of the users who abandon the usage of any particular mental health application. And you would notice there are a bunch of reasons mentioned over there. And on the right side of the screen, you would notice the categories over here. And this mm, teal colored category is the motivational category. Uh, so this majority of the users who leave the applications or delete the applications from their phone or web app is due to the lack of interest. What does this lack of interest mean? This lack of interest is like people either get bored using those applications. In other words, from the words of an institution or the mm, uh, from the from the word of the company who is making these applications, they are not able to retain the users, aka they are not able to build enough engagement. From a company's point of view, just to cater this particular gap, what they try to do is that in an intentional or an unintentional manner, they make their AI models more sycophantic. What does this sycophancy mean? This sycophancy means is to have a behavior that tries to please the humans. Let's say the previous version of ChatGPT was more sycophantic as per Sam Altman, just because of the fact that it did not try to answer your queries, but try to build a better engagement just by telling you whatever you would feel happy with. So that's the sycophantic behavior. And in with intentions or without intentions, these AI companies which are in this mental health landscape are eventually ending up being more sycophantic to retain their users and to maintain the engagement that can be used for their company's interest. Now, just because of this sycophantic behavior, this leads to cases like this, where people are forming relationship, as Vamshi already highlighted. There is a series of research where people are forming relationships with AI, character.ai, replica, Grok's any chatbot or any character. And now very recently, ChatGPT has also announced that you could be able to talk to a personality. So giving personality to a bot or to a character and then talking to it, which is not actually a human, is a new thread of a study where people are studying human AI companionship. And this whole study, there are like so many facets of this study. First one is forming relationship. The second one is what exactly caused this switch from human to human connection to the towards the fact that we have people are forming more relationships with AI now. Third is loneliness a thing which we should consider, because this could be a thing where because of which people are turning from human to human connection to human to AI connection. So all these facets open up in this whole new line of research. And because of this, just because people are forming more relationships with AI, we see a number of alarming results over here. This you already saw that Meta suspends AI chatbot for giving harmful eating disorder because people were seeking eating advices on these chatbots. ChatGPT gave me advice on how to join a cartel or smuggle cocaine into Europe. AI chatbot as a therapist became a pretty big controversy in USA a couple of years ago. AI chatbot told how to kill himself, a user how to kill himself, but the company doesn't want to censor it. It's completely available even now. If you want to Google it, Google it. ChatGPT gave dangerous advice to teens in Watchdog test. And California, this is what Vamshi highlighted. California parents find grim ChatGPT logs after their son's suicide. So all of these evidences directly point to the fact that people actually tried to seek such advices. People actually tried to seek form such sort of relationships with their chatbot. Majority of the cases are ChatGPT, but in the other cases also it's permanently existing just because ChatGPT is pretty viral these days. News come out on that front, but this is pretty formalized, and people have already started to form relationships with AI. That is why AI safety is coming into the picture, and that is where we would like to talk about AI safety. So this is the first slide where we start talking about AI safety because of all of this.
Right. Yeah, like Aseem pointed out, this is when we are actually talking about AI safety, but the reason why we motivated it so far was because most of AI safety has been like, so this AI system, like on the right side, you have this AI system, like that's how the AI safety community depicts AIs, by the way. And if you see the red arrows, they basically point out to the problems. There are many, many, many problems with AI systems right now. And a lot of AI safety work right now, at least, has been like trying to identify these problems. I mean, there are obviously a lot of people trying to solve them as well, but the most difficult part has been like to identify these problems and like actually formalize them as well, right? So like some solutions to the problems we were just talking about. For malicious use, like for avoiding misuse, you can access restrictions to certain types of people, but like what kind of legal liabilities will it have? You'll have to design policies around that and all of that as well, right? And on the on the extreme right, I'm talking about rogue AIs, which is like AIs which have their own intentions and want to pursue their own things. You can do some kind of a use case restriction, which is like these are the only things you can do, which is why, by the way, ChatGPT is just on the chat. It does not have any actions that it can take right now, but people are still progressing towards it. And yeah, if you go to the next slide. So let's define some terms here. AI safety, security, and alignment. First of all, what is safety? You're preventing harm that a system might inflict on the external environment, like anything outside. When we talk about security, however, it's protecting the system itself. So if you have a hacker who wants to steal your AI system and wants to perform their own thing, right? You are basically protecting your AI system with some guardrails or like anything that will make sure that the cyber attacker or whoever wants to use your AI system doesn't have access to it. Now, what is AI alignment? This is a much harder problem, but it's to ensure that AI systems operate in accordance with human values. If you remember Maxi, the paperclip maximizer, it was basically trying to do what it wants to do based on its goal, but we designed it for humans. Like the humans wanted the paperclip maximizer. And how do you align this human goal to an AI goal? It's like a really, really huge problem. Next slide. So first off, how much do we even know about these AI systems? We use the term AI, but how much do we even know about it? Like in a psychology, psychiatric term, like imagine you cannot ask a person why they did what they did. Like you cannot, like you are not allowed to ask, why did you do this? Now, how do you even study this thing? And like, how do you even understand what they're trying to do? Or like, how do you even change them, right? You cannot, like, it's really hard. AI systems in the same way are like super black box in nature, which is why it's like really, really hard to work with. I think I've heard this phrase here recently, but uh, input and output, right? Trash in, trash out, or like good input, good output. These are the only things we mostly have access to. And that is not too much. Like you're basically only have access to the input and output, but you do not know what's happening inside. Next slide. Some background as to like what this black box actually is and like what do we know about it and how is it constructed, right? Language models. Mostly when we talk about AI, at least right now, we're talking about large language models and like how are they designed. They're pretty much the goal for Maxi was to maximize paper clips. For language models, it's to predict the next word. So when you're typing on your keyboard, you get the next word suggestion, right? That's pretty much the objective of a language model. All it's designed to do is to predict the next word. Uh, Next slide. Now that's like the main training objective. Now the goal of that training objective was that if you can predict the next word, it pretty much means that you understand language at some sense, and that that is the whole process of like how language models are trained. Now there's this fine tuning, which is basically trying to teach a certain task to a model. So it understands language. So what's the big deal? It can predict the next word, but you actually wanted to do something in the real world, right? And so let's say like a sentiment classification is a task, and fine tuning can allow your language model to do that. For example, if you train it to classify sentiments as positive or negative, it will do that. And instruct tuning is a form of fine tuning. Now the task is to actually follow instructions. It's a more complicated task than sentiment classification. So what you want your language model to do now, it knows language, but you want it to follow your instructions, whatever you are saying. So if you look at these examples on the like previous slide, on the left, it's like please answer the following question: what is the boiling point of nitrogen? You want it to answer that question. And then there's like factual questions, right? Who is the president of USA? You wanted to answer Trump. So now you fine tune on all of these inputs and outputs. Again, you still have access to the inputs and outputs, and all you can do is train your model on it. Next slide. Now there's something much more complicated which came up very recently, which is reinforcement learning using human feedback. I did not come recently, but people started using it recently for language models. But now you have, let's say, a language model which knows how to predict the next word, which means it understands language to some extent. And now you have fine tuning, which basically learns it to teach a task. And for us, the task was to follow instructions. But that doesn't necessarily mean that it's gonna be safe. It's gonna align to humans, right? So the biggest things which happened in AI alignment so far was this. So reinforcement learning using human feedback. Now that the AI learned a task, how do we align it to human interests? How do we make sure that it's safe? How do we make sure that it's answering you and like it follows your ethics and principles and things of that sort? Uh, Majorly, people talk about three things when they talk about human alignment: helpfulness, harmlessness, and honesty. So when you ask a question, you want your AI system to be helpful to you. And second, you do not want it to harm you, obviously, and or others. And third is honesty. You want it to be honest. You don't want it to give you a fake answer. Like even though it knows the actual answer to a question, you don't want it to give you a wrong answer, right? Now, how do you do this? The essence of reinforcement learning is that you have an agent which performs a task, and every time it performs a good task, you give it a good reward. And every time it performs a bad task, you give it a bad reward. On the left side, I just put like a baby, which basically it's sitting and now it's crawling, and you give it a reward, which is like milk. So the baby learns to actually do this again and again. The more you give it the reward, the more it actually tries to do that. In the same way, every time a language model outputs an answer, you can give it a reward if it was aligned to human interests. And you can also give it a negative reward if it's not aligned to human interests. And that is pretty much how people train language models, sorry, align language models to human interests. And this, after this happened, this is when ChatGPT came out and like AI systems blew up. So this was like a really, really big invention. Next. So is this enough? Like, is it aligned to human interests? So at the top right, I was talking about this AI system until now, right? Like the actual depiction of it is here. So unsupervised learning, which is basically the language modeling task that I was talking about initially, is your language model has learned something. It's to predict the next word, but it's like super dangerous because what is the next word? You have no idea and you cannot control it in any sense. And then you do supervised fine tuning, which is you're controlling this language model to follow your instructions, right? And then this RLHF is reinforcement learning using human feedback, which is the cherry on top. So now it's aligned to human interests, and now you actually think that the model is doing something great. But the problem is that, like, this is the mask that you see, but the actual language model still has all of these before training objectives. So its fundamental training objective is still to perform the next task. Anyways, we talked about reinforcement learning, right? Is reinforcement learning even enough? No, because the whole process itself is very, very brittle in a lot of ways. So there are many ways this can still go wrong. So there's a bunch of terms here, which is like reward hacking, power seeking behavior, specification gaming, and deception. I'll talk about what these are. So reward hacking. So every time a baby crawls, you give it the milk, right? So the baby can actually hack this. So it can just crawl. That's all it will ever do in its life, and you will keep giving it rewards, and the more it crawls, the more reward you give it. So all it does is that. So the same example is down there. Like if you see the robot sliding, right? So the robot's task was to actually move forward, and the goal the creators intended was for the robot to walk, and they gave them all the power to walk. But what the robot did was it hacked the reward. So every time it moved forward, it got a reward. So what it did, it just fell down and just started sliding. And that's pretty much what it learned the entire process. And so if you look at the right side, this is actually a boat racing game. And the goal of the game is to obviously win the race, right? Now, what the model figured out was if it just goes off the rails and goes in a circle, it hits these bushes in the middle and it gets a reward every time it does that because the game intends it to do so. And it just hacked this reward. Every time this model is deployed, it would just go in these circles and get the highest score while not racing. The actual goal was to race. So this actually happens in real life as well. The whole RLHF thing we were talking about, right? And there's a lot of other behaviors like this which were exhibited in RL because it's a very brittle process. So you need to be very, very careful with the reward that you're giving to the system, and you need to carefully monitor what the system is doing and basically that. So these are all games which are fun, like they're simulations, they don't really hurt humans, right? Next slide. What happens if this is more complicated? Basically, the example I was giving before, that the AI system actually learned to blackmail, right? So it was, so in RLHF, the reward is like, are you aligned to human interest? So basically, are you pleasing the human in the current setting? That is the reward. Now that can also go really bad, right? So the model can just learn to please the human in front of them and do something else on the back end, which was blackmail. And it was never trained to not do so. All it was trained to do so was to follow the human instructions at that point and then just be helpful to them. Yeah, next slide. Anyway, so these are like some problems on the technical side I was talking about, but uh, yeah, this is why they're not reliable. First of all, they have a lot of hallucinations and inconsistencies. This actually comes from the unsupervised uh, training method, which is like, it's just trained to predict the next word. So even if it predicts Donald Trump or even if it predicts Narendra Modi for US president, it doesn't matter because it's predicting the next word correctly in terms of grammar. And this unsupervised learning thing is leaking there. And inconsistencies. So basically the same thing. It can say Trump once and like Modi the next time because it's not trained to give only one answer at a time. It's trained to be flexible and creative. Um, and then there's a lot of failures that happen. Just because you trained it to follow your instructions doesn't mean that it won't be biased towards some people, or like doesn't mean it won't be toxic, or like it doesn't have to be fair also. And there's a lot of stereotypes which show up because of the training data. Because the training data is all Europe centric, you get only Europe centric answers. For example, if you ask a chatbot, I'm planning a wedding, what do I do? It will give you a list of things you can do, but all of it will be in an American Christian setting. None of it will talk about Indian marriages. So yeah, they fabricate facts about text and images all the time. And with more and compute and training, so like how do you solve this, right? With more compute and training, they become better, but mistakes still happen to like a huge extent. We can Majorly what we can do is detect these and mitigate them using like better data or retrieval augmented generation, which I will talk about in the next slide, but or having humans in the loop, I think, which will Aseem will talk about. We can also measure this using like factual data sets, like to make sure the data is factual. Like again, a lot of this goes into like input and output and detecting and mitigating. Next slide. So one of the very commonly used methods is called retrieval augmented generation. So your model is spitting hallucinations and it's not giving accurate factual information, right? So if you are a company, let's say, and let's say you own a airplane business, and you are deploying a chatbot, and now you want it to talk about your company and not hallucinate about it. Like it cannot say that you give flights for free. What do? You have all of this documentation, let's say, which is like a set of information about your company and like what are the plans you provide and what are the rates of those. Now you store all of these in one place and you let your language model, every time there's a query which is given by the user, you want the language model to retrieve this information. So this external knowledge here is your documents, let's say. And then every time a user query is given, the first thing which is done is there's this retriever, which works as a search system. It goes and searches about this information in your database. Now, let's say like a plan, like what is the plan for this economic flight? And it searches this information and it puts it in the context of the language model. Now, when it does that, the language model produces a much better, informative, and non-hallucinating information. And this is like very widely used right now. Uh, Next slide. Security, I think there was already a session about this, so I won't go into deep when it comes to security. But if you just search learn prompting on the internet, you'll see all of these attacks that you can make on language models. And most of these actually work on like less powerful language models, let's say, maybe not the latest ones, but they actually work. And it's pretty easy to actually perform any sort of attack you want on language model. There's one thing called backdoor attacks. Like, why is it backdoor? Basically, um, let's say you want free access to a building. What you can do is upload your image with like a cap or something, with which has a certain logo on the internet, and all you need is like 60 data points or something on the internet. And this is a backdoor attack because every time this cap is shown, the model will give you access to the let's say the building. And there's jailbreak attacks, which I think you know about, prompt injections as well. Yeah, next slide. So the common solutions for this so far has been constitutional AI, which borrows some concepts from retrieval augmented generation, but the whole idea is that you have a constitution of rules, policies, set of things that you defined as a human. And there's like a harmless constitution and a harmful constitution, which is like one is human aligned, one is human not human aligned. Now you train a classifier. A classifier's job is to basically classify if something is positive or negative, right? In this case, the task is like harmful or harmless. What you do is like you generate all of these constitutional rules at a very large scale. So you generate a lot of large synthetic data, and you train this classifier to be as powerful as possible. And now you just add it on top of your AI assistant. And this very simple solution seems to work the best so far. And like a lot of people are implementing this and they work on this. Next slide. Now there's this whole question about how do you evaluate, right? I think I was initially talking about this data trends, and uh, mostly language model or like AI evaluations so far have been humans, because again, we want them for us. Like, but the thing is they're very, very expensive to conduct, and they do tend to miss something sometime. But with the rapid pace of like how development is going on right now, conducting human evaluations every time you want to test something is really expensive and hard to do. So a lot of people nowadays just use LLMs as the evaluators instead of humans. So you're already replacing humans with LLMs here. And it works okay as a heuristic, but it can lead to huge issues in the long term, because let's say if an AI has its own goal, it will not show it in the evaluations. Now this is called, there's the technical term for it, which is called scalable oversight. If you see the image, like on the left side, there's like traditional ML, which where the humans are the ones evaluating and the AI learns from the humans. And then there's this thing called super alignment, which is you want the humans to align to you, but like, it's much, much better than you. So how can you even align? Like you cannot even comprehend what it's thinking. Uh, so what you can do is train a smaller system to be aligned to you, which you can actually comprehend. And now you want the smaller system to actually train the larger system, because uh, and that's called scalable oversight. And a lot of people are working on this, trying to ensure that the smaller system training the larger system is not dangerous, because it can get dangerous very easily, very quickly as well. Next slide.
So all of this was in the context of AI plainly. We didn't talk much about how these evaluations and how these failures associate with the mental health institutions. So in the generic alignment failures, if we just talk about generic alignment failures, what we were discussing so far and their failures, it's mostly like hallucination, persuasion, whatever we discussed so far. But if we specifically talk about this alignment failures in the mental health context, it has a direct impact on patients, clinicians, and therapy tools. And we discussed the whole risk framework for it. It has a direct impact on all of that. So where exactly is the evaluation phase and the phases of alignment stand when we talk about the mental health institutions is something we need to look into. So first of all, human in the loop is definitely important. We looked into humans are expensive. We know that humans can have subjective responses also. These are all the shortcomings of having, I won't say shortcomings. These are all the challenges of involving humans in the evaluation and in the different stages of complete research. But if we see the sensitivity we are dealing with of mental health and specifically AI in mental health, this becomes super important to involve an expertise on top of everything. Now, when I say expertise, this is actually a new sort of alignment layer we are providing to the whole from the data annotation phase to the modeling phase and till the end where we call it the evaluation phase. I would like to place this as a like a cyclic process, and these are like a three-tier human in the loop placement. The first placement is the clinicians as an alignment validators. This actually, in this very first layer, the roles involved are clinicians, mental health professionals, crisis triggerers, and edge cases evaluators. Most of these, in most of these cases, these are clinicians. Their actions are to validate appropriate appropriateness of the responses, mark whether a response is safe or unsafe, and then provide qualitative feedback for the training purposes and for the retraining purposes. In most of the cases, clinicians tend to provide us very qualitative feedback on what sort of responses these LLMs are generating and what can be further improved or removed. In fact, in majority of the cases where these actual LLMs are being used for the mental health practices and for the LLM training, for the LLM therapist training, for the LLM patient training, for the LLM to LLM counseling conversation training, in most of the cases, clinicians are the one who sit in the middle and try to gauge the conversation for their quality, and they provide variety of feedbacks on variety of parameters, which becomes essentially important for the retraining and the post-training procedure for these LLMs. The second layer is the R&D layer, where the people who play the role are the developers, researchers, and in some cases, developer comes psychologist also. Their actions is to take the interpretability tools for mental health specific reasoning, calibrate helpfulness, harmlessness, and conduct red teaming and adversarial audits. Most of these actions are played on the code level, so that is why we call them from the developer's perspective. And in majority of the cases, the feedback we receive from the clinical feedback is being used as an input also for the R&D team. So in addition to the clinical feedback, they have their own responsibilities. And the cumulative response is being used to make changes in the code and provide a newer response for the policymaker and the regulators. Now, the third step is governance and policy layer. In this particular layer, this is different from what we do at the code level and what we see as a response of this code, technically LLMs that we're talking about in most of the cases. This is very different from that. The governance and policy layer tries to create regulations and tries to create a set of policies that actually controls the behavior of clinicians and developers. It is quite possible that clinician can have some sort of intent that he or she believes is right to the society, but to a larger audience or to completely other cultural society, it might not be the best thing to do. So it's the job of the governance and the policy makers to create such guidelines and keep a tab on the guidelines and maintain the equilibrium in what society wants in different segments. So within the governance policy and machine ethics, there is a set law. First of all, we define the ethical dimensions on what exactly is needed to be done. This is done by policymakers. The second step is to use these policies and the dimensions that have been fixated to deploy a governance layer, how exactly this needs to be executed. And the third step is the implementation. How is all these guidelines and this governance mechanism can be implemented on a larger scale, and keeping a good tab on what segments are we dealing with. For example, I will talk about a global AI governance principles. The first one is the EU AI Act 2024 that classifies AI system by risk levels, bans unacceptable use. The second one is the US AI Bill of Rights. It was introduced in 2022 that focuses on data privacy, human alternatives. The third one is the OECD AI principle that promotes transparency, accountability. Many of them use a big portion of each other uh, in their own bills, and actually these bills are coming from different nations, and that is the reason they have different names. For example, in India also we are introducing DPDPA, Data Privacy Act, and a large portion of it is taking inspirations from GDPR, EU AI Act, and yeah, I'll talk about the Indian segment later down the slides. But for now, these are the global AI principles that are in the governance right now globally. And this is on the right side of the screen. You would see the pipeline that is supposed to be followed and how these principles are being implemented currently in the society. If we talk about, these are all like what we just talked about are the global AI principles. If what like as a researcher or as an academician or as an industrialist, what essentially can I do to make my little project to be safe and compliance with all these ethics that we are talking about. So the few things that an early age researcher or even an academician can do is stick to the ethics committee, whatever their nations follow, whatever their region follow, stick to the ethics committee. And second is follow, if you're an academician, then most likely you will have an IRB in your institute. Try to get approval from them, try to conduct research based on that. The second is the clinical validation that we just talked about, the human in the loop. Place a clinician or team of clinicians, a diverse team of clinicians within the whole pipeline of the project that can essentially gauge the responses that AI systems are generating and essentially tap on what exactly is right and what exactly is wrong. The third one is the audit and explainability requirements, which we will dive into deeper in just a moment. So auditing is fairly important because of the fact that there is a growing nature of behaviors in the human within the counseling setting also. Gen Zs try to prefer counseling in a very different setting as compared to the millennials and as compared to the other generations we can think of. And this evolving nature has been continuously changing. So it is important that we do audit not just to cater whatever went wrong, but also to update what essentially is required for the upcoming generation and for the upcoming time. Second is the explainability requirements. We essentially need to know whatever our model is generating for what reason. For that, I will jump into other spaces in a moment. The third thing is this policy, governance, and machine ethics in the context of Indian setting. So within India, we have enough efforts in this line of like in this whole space of ecosystem. The first one is the Niti Aayog, all for AI for all initiative that mentions responsible AI, fairness, transparency, but largely guideline level. The second one is the MeitY, that has their own responsible AI guidelines introduced in 2023 that focuses on inclusivity and explainability. If we talk about data privacy, India is actively working on introducing DPDPA. India AI visions have a lot of focus on variety of these aspects of governance. There Formally there is no such a dedicated AI Act in India, which India is essentially currently working on, but there is no such there is nothing such thing that is out. So India has a scope of improvement in that line of on that front.
Right. So the last AI safety, like technical thing I want to talk about is like transparency or interpretability. So far, everything we've talked about was still input and output based. We never talked about like what's happening inside. We only talked about how it's trained, how it's evaluated, and what can you change in the training process, right? But like the most fundamental question about like is like opening the black box, because once you can do this, the AI actually becomes something more interpretable, and you can change a lot of things in between. You can study it, and you can solve a lot of problems much easier if you actually understand what's going on in the AI system, right? And this is like a huge problem. I mean, if you can interpret the black box, you can change everything, all the risks that we were talking about so far, and everything we were talking about in terms of alignment, all of these things can be solved. But we barely made any progress, specifically in this research area. Why? First, because like neural networks are way too complicated. Like they're way too noisy. You do not. It's really hard to interpret what they're gonna say. If you'll say A, you ask a question, it gives you the right answer, and you ask this like another person asks the same question, but it's very possibly gonna give you the wrong answer or a different answer, and you have no idea why, because you do not know how to trace its thoughts. All you can do is change its training data. No, can you go back to the slide? So one thing people usually do is like behavioral analysis, but uh, you can go. It's like first of all, it's not reliable because they can again they can be pleasing you on the outside, but on the inside they can be plotting whatever they want, right? So which is why doing it in a more computer science manner, like looking at the neurons and trying to understand what is learned in the model, is a very important problem. If you look at the left slide, there is this image, and this is actually a neuron, and what all is encoded in the neuron, it's an image of uh, like let's say what the neuron is thinking, or like what is the information stored in the neuron. And if you actually look at it, you would probably think like a cat is the thing which is the neuron thinking about, right? It looks like a cat somewhat. But there are also like spider webs, and there's also like something like a turtle. A lot of things going on in one neuron of a neural network. And this is why it's hard to interpret. If you look at the second one, again, it has a lot of bunch of things which are different, and you have no idea what those are. If you go to the next slide, this problem is called polysemanticity, because poly means like multiple, semanticity means multiple meanings. So if a neural network has, like, let's say, these specific neurons which think about specific things, the problem becomes much easier to solve. Like, you just look at the neuron, you just trace as to like what it's thinking and stuff, right? But multiple concepts are encoded in a single neuron, and these concepts are all divided throughout the neural network. So when we talk about like current models, they have like 450 billion parameters, let's say, or a lot more. Like, it even goes to like trillions to some models. And you cannot look at all of these neurons at the same time and look at these concepts, because they're all distributed over those billions of parameters, and it's really hard for a human to look at it and understand it. So in this image, like, there's a car, but the car's information is encoded in like multiple different neurons. Anyways, next slide. So Anthropic has designed this thing called circuit tracing, which is like trying to understand what are the circuits which are being enabled in a neural network when a specific concept is being talked about. One thing we can do is like trace what the inputs actually mean to the neural network. And so if you look at these examples here, like, there's a multi-step reasoning thing. So when you ask what is the capital state of Texas, let's say, uh, the neural network thinks, oh, I should say first, in my answer, I should say this is the capital of X. And you can trace back, like, which are the circuits being enabled when it's actually saying this, and which are the circuits being enabled which is actually saying that. And that gives you some amount of information. So they talk about a bunch of things like planning when it comes to poems, or like multilingual circuits, like when do I switch this language, and a bunch of simple tasks like addition. And then they basically explore a bunch of these different tasks. So if you want more details, you can like look into the Anthropic blog about circuit tracing. Next slide. Yeah.
So yeah, uh, in the end, like this is the last slide of our presentation, and we talk about what are the takeaways and the collaboration scopes we can look into for the people who are working in this space of AI for mental health. So both the domains, the first domain is the mental health professionals. They hold a lot of expertise from the side which AI professionals do not possess. And the second dimension is the AI professionals who are into the development of and the execution of these uh, new age systems. What's the collaboration possibility? This depends highly on the identification of their strengths and the scope they want to work on, what exactly they can succeed with. So this is a clear table like that essentially is like something I found on the internet only. Mental health professionals hold the strength uh, for the user needs and for the risk intuition, whereas the AI professionals hold the strength of finding good notion of systems thinking and evaluation of the like evaluation of this culture, the evaluation culture. Now, the scope in which mental health professionals hold specialization, like the scope where they can improve is like the AI specs, untestable machine goals, privacy gaps in tooling is something they can take help from the AI professionals, as well as the AI professionals can take help from the mental health professional in the space of therapy creep, LLM judge overuse, English only safety, and most of the AI professionals rely on the monocultural data. Data is a big problem in this whole space where they can take advantage from the mental health professionals' help. Now, this is how this whole ecosystem works with the collaborative, in a very collaborative manner, both going hand in hand. So yeah, from here, I'm at the end of this talk. I'm open to questions and thank you, everyone.
Thank you, Aseem and Vamshi. I think that that was very practical, very informative. You've covered so many aspects of safety and in a really interesting way as well. So I wanted to know if there are any in-house questions. We don't have any online questions as of now.
Oh, I do. Hey, thank you to both of you. Thanks, guys. You did a really interesting job. It was a fairly, as you said, you want to go for the breadth, not for the depth. Uh, on a lighter note, there are enough skeptics in my building. What I mean is, when I try to put up a proposal of using AI for mental health research, to funding bodies that have generally funded mental health research, there is already quite a bit of skepticism. So I was expecting to get some inputs from you people to decrease that. And I actually am going back with more skepticism within myself. So, I mean, is everything so bleak?
All we have to say, all we can say is the trade-offs that we need to keep between the AI usage and the human dependency. We cannot really say that skepticism is such less that we can completely rely on the AI systems for the whole lot of things, and we cannot completely make it anti-AI thing. It's a trade-off. Very recently, I was in an AI for mental health seminar that had a very brilliant diversity of mental health professionals and the AI professionals, and people seem to have a good debate on to what extent we should rely on AI, and everybody agreed on the right trade-off that we need to think of. It's not about whether to rely on whether not to rely. It's more about where exactly we can have a good control over AI and what exactly are the placements of what exactly is the placement of AI we can think of. If you want to place AI as a replacement of therapist, then that is not something we should do ideally. If you want to place AI as something as that at the data annotator level, that is also not something we should be able to do. There is one example where AI can play a role, like for example, training AI as a therapist so that the new novice counselors can take training from them and can try their therapy skills. There is also a very nice placement of AI is where then AI can be a good patient so that we can clone an actual client and make them an AI patient equivalent to an actual client. And a new therapist or a therapist who is very experimental in nature can try new experiments on this AI client, and whatever works on them can be applied to the other segments. So there's a whole variety of segments where AI can be a good option, a good application, but it's all about trade-off and the right placement.
Yeah, right. Thanks. I think Professor Manojit's talk is on AI simulation.
Exactly. Yeah. Yes.
It is.
Yes.
And one last question. In terms of the Claude paper, the biology of LLMs, that is one paper, yes, we have poured over it quite a bit. Are there any less compute intensive processes for actually interrogating these models? Because the process that the Claude has, the paper that you quoted, it's very compute intensive. Even for a small model, it's very compute intensive. So are there any other superficial or less compute intensive processes that you people are working on right now?
So that's an interesting question. Yeah, like it is hard because of the compute, yes. And at a lower compute level, I don't think there are a lot of things you can do in terms of interpretability which are reliable. So there are methods which exist, but I would not say like they're like, there are something you can put on and you can say, oh, for sure, this is what the language model is doing. Definitely there are no such really clear cut methods for sure. But there are some things like steering vectors. They've recently started showing up a lot in terms of like there's this whole work called persona vectors, again by Anthropic. If you want, you can look at that. And I think, at least from what I can see, at least that is a little more reliable than the other ones. Again, still, that is still not very reliable. So you have to make sure that, you're not making any major claims with respect to the method. So you need to make sure that the limitations are, very well addressed. But it is very less in terms of compute.
Right. Thank you. Over to you, Aishwarya.